When you think of Jupiter, you might think of its massive size, or colorful bands of gases stretching across its face. Or you might think of the iconic storm, that huge, churning red hurricane, twice the size of Earth, that's remained a signature of our solar system's largest planet since for more than a century. This is Jupiter's Great Red Spot, and it has captivated humans for generations.
Hey everybody, welcome to Studio 64. My name's David. I've been searching the interzones for more science, space and tech news to share with you. Came across this at SciTech Daily. Yes, what's happening with Jupiter's Great Red Spot? The solar system's largest storm could finally disappear. Oh, okay. Well, this should be interesting. Let's see. Well, there's a picture of Jupiter and its famous Great Red Spot that we're all familiar with. And it says here, Jupiter's Great Red Spot, or GRS, an easily visible anticyclonic vortex and the largest such vortex in the solar system, has intrigued scientists since it was first observed through telescopes centuries ago. Recent research, including simulations and space mission data, has investigated its formation, stability, and the possibility of shrinking or disappearing in the future. That's very, very interesting, isn't it? As I say, you know, I'm not a scientist myself. I just love all science and sharing science, space, and tech news. Are there any astronomers out there? Please feel free to comment down below and below the video in the comments section, because we'd love to hear from you. This should be really interesting. Now, Jupiter's Great Red Spot is a giant vortex that has existed for at least 190 years. Recent studies suggest it is distinct from an earlier observed spot, and simulations explore how Jupiter's winds may have shaped it. The GRS has been shrinking, and future research will focus on its sustainability and potential future disintegration. Now, as usual, I'll leave the link to the main article below the video, so you can pop in, check out these embedded links, go for a bit of a deeper dive if you want, beyond the main article. Makes for an interesting read, believe me. There's often, you know, further in-depth articles and everything else with some of these links, but this particular one says, Jupiter is the largest planet in the solar system and the fifth planet from the sun. It is a gas giant with a mass greater than all of the other planets combined. Its name comes from the Roman god Jupiter. Cool. That's very interesting indeed. Yes, Jupiter's Great Red Spot, or GRS, stands out as one of the most iconic features in the solar system. Its massive atmospheric structure, currently spanning a diameter equal to that of Earth, is easily recognizable due to its striking reddish hue, which contrasts sharply with Jupiter's pale cloud tops. Even small telescopes can capture its distinct appearance. The GRS is a gigantic anticyclonic vortex with winds reaching speeds of 450 kilometers an hour along its outer edges. It holds the title of the largest and longest lasting vortex in the atmospheres of any planet in our solar system. However, the exact age of the GRS is still debated, and the processes behind its formation remain a mystery. Interesting. Speculations about the origin of the GRS dates back to the first telescopic observations made by the astronomer Giovanni Domenico Cassini, who in 1665 discovered a dark oval at the same latitude as the GRS and named it the Permanent Spot, or PS, since it was observed by him and other astronomers until 1713. Now, track of it was subsequently lost for 118 years, and it wasn't until 1831 and later years that S. Schwab again observed a clear structure, roughly oval in shape and at the same latitude as the GRS. That can be regarded as the first observation of the current GRS, perhaps of a nascent GRS. Since then, the GRS has been observed regularly by means of telescopes and by the various space missions that have visited the planet right up until the present day. Yeah. And of course, other planets, such I believe, is it Neptune or Uranus? They have their, being gas giants, they have storm spots as well, though they're not red, of course. But I don't remember which planet it was, or is it both? Let me know down in the comments if you can elucidate and educate me, because I'm just an old nerd who loves science. Yeah, this is amazing. Just grew up reading about this and watching the Voyager space probes when they were sending us information back, and just think it's absolutely incredible. It's a beautiful colours. Nature's definitely an artist. Definitely an artist. Just blows me away. Yeah, look at that. That's incredible. Gorgeous colours. Very interesting indeed. Yes. Analysing the GRS evolution. Now, in the study, the authors first analysed the evolution of its size over time. Its structure and movements of both meteorological formations, the former PS and the GRS. To do so, they used historical sources dating back to the mid-17th century, shortly after the invention of the telescope. I wonder what... is this... As I say, if there's any astronomers there, can you let us know? Does the GRS sort of serve any purpose? Like, is it something necessary for Jupiter, or is it something that is a natural part of its cycle? It happens every few centuries, or is it something that's just like a storm on Earth, but this one happens to be going for a long time? Love to know that. Here we go from left to right. Enrique Garcia Melendo, magnificent name, by the way. And Agustin Sanchez La Viga, even a better name, that's fantastic. And John Legarreta. Looks like your parents let you down there, John. Sorry to say. You know, and then you're followed here by the credit by Fernando Gomez. And you've got to say it like that too. Look at that, magnificent. Enrique Garcia Melendo and Agustin Sanchez La Vega. Absolutely fantastic. Brilliant stuff. From the measurements of sizes and movements, we deduced that it is highly unlikely that the current GRS was the PS observed by G.D. Cassini. The PS probably disappeared sometime between the mid-18th and 19th centuries, in which case we can say that the longevity of the red spot now exceeds 190 years at least, explained Agustin Sanchez La Vega, professor of physics at the UPV/EHU, who led this research. The red spot, which in 1879 was 39,000 kilometres in size at its longest axis, has been shrinking at about the current 14,000 kilometres, and to about the current size of 14,000 kilometres, and simultaneously becoming more rounded. Okay, so sort of becomes more elliptical as with speed. Interesting. Recent findings and simulation studies. Now, what's more, since the 1970s, several space missions have studied this meteorological phenomenon closely. Recently, various instruments aboard the Juno mission in orbit around Jupiter have shown that the GRS is shallow and thin when compared to its horizontal dimension, as vertically it is about 500 kilometres long, explains Sanchez La Vega. Now, to find out how this immense vortex could have formed, the UPV-EHU and the UPC teams carried out numerical simulations on Spanish supercomputers, such as the BSC's Mare Nostrum 4, part of the Spanish Supercomputing Network, or RES, using two types of complementary models of the behaviour of thin vortices in Jupiter's atmosphere. Predominating on the giant planet are intense wind currents that flow along the parallels, alternating in their direction with the latitude. To the north of the GRS, winds blow in a westerly direction at speeds of 180 kilometres an hour, while to the south they blow in the opposite direction, in an easterly direction. At speeds of 150 kilometres an hour, this generates a huge north-south shear in wind speed, which is a basic ingredient enabling the vortex to grow inside. Okay. I wonder, meteorologists, if there's anyone out there watching this video, feel free to comment, and if we had the equivalent on Earth, what sort of damage could it do if we had a great storm like that? Now, this is interesting to me. The Spanish Supercomputing Network, or RES, was unaware they had one. If anyone knows about it, please comment. I should do some research myself and make a video on it. It sounds fascinating. Now, in the research, a range of mechanisms were explored to explain the genesis of the GRS, including the eruption of a gigantic superstorm, similar to those rarely observed on the twin planet Saturn, or the merging of multiple smaller vortices produced by wind shear. The results indicate that, although an anticyclone forms in both cases, it differs in terms of shape and dynamic properties from those on the present GRS. We also think that if one of these unusual phenomena had occurred, it or its consequences in the atmosphere must have been observed and reported by astronomers at the time, said Sanchez La Vega. That's interesting. Got a little video here with some information on that great red spot itself. We'll check that out, I think, and then we'll carry on the conversation when we come out the other side.
When you think of Jupiter, you might think of its massive size, or colorful bands of gases stretching across its face. Or you might think of the iconic storm, that huge, churning red hurricane, twice the size of Earth, that's remained a signature of our solar system's largest planet since for more than a century. This is Jupiter's Great Red Spot, and it has captivated humans for generations. Samuel Heinrich Schwab, an amateur astronomer, saw Jupiter's Great Red Spot for the first time in 1831. Therefore, we know the storm has been around for at least 150 years. However, it could be even older. Some astronomers believe that the Great Red Spot was the permanent storm that Gian Domenico Cassani was referring to when he wrote about it in 1665. Gian Domenico Cassani is also the namesake of NASA's Cassini mission. Even in NASA's James Webb Space Telescope's new image of Jupiter, it clearly shows Jupiter's iconic red spot. It's so brilliant that it appears white. It seems to be that the white streaks and patches are caused by sunlight, being reflected off unusually high-altitude clouds. So what exactly is the Great Red Spot? And will it disappear one day? Let's find out. Jupiter's Great Red Spot is a massive storm that circles the planet in its southern hemisphere, and is almost twice as huge as Earth. Winds are generally calm near the storm's center, but they may reach 270 to 425 miles per hour at its edges. Even the strongest storms on Earth, which have wind speeds of up to 175 miles per hour, travel at less than half that speed. The storm is contained by an eastward-moving atmospheric band to its north and westward-moving band to its south. Those swirling bands are also what formed the storm in the first place and have kept the storm spinning for more than a century. Jupiter lacks a solid surface, which helps explain why the Great Red Spot has lasted so long. The 70-kilometer deep sky of Jupiter is made up of layers of water ice, ammonia ice, or ammonium hydrosulfide clouds. It is thought by scientists that an ocean of liquid hydrogen exists underneath these layers. The planet's core is located under that ocean, but scientists are uncertain of Jupiter's makeup at this time. On Earth, storms begin to weaken and disintegrate as they make landfall, but because the Great Red Spot cannot make landfall, the storm may continue for an extended period of time. Observations reveal that the storm occasionally shrinks and grows, but is currently on a shrinking trend. What once was 3 times the size of Earth now only stretches twice our planet's diameter. Great Red Spot observations have been accurately recorded by observers since 1878. In a recent study, a group of researchers compared historical data with fresh ones from a variety of current instruments, including NASA's James Webb Space Telescope. And some experts say the storm may continue to weaken over the next 10 to 20 years, and it might even vanish. And as always, if you want to learn more about space and stay up to date, like, subscribe, check out our previous videos, and visit our website if you love reading at www.nasaspacenews.com. Thanks for watching.
Well, that was absolutely fascinating, isn't it? Yeah, we've been looking at this for quite a while, if that Great Red Spot should disappear. I have a funny feeling it could be a cyclic thing, you know? Stay around for a couple of 100 years, and then, like storms on Earth, they lose energy, you know, and blow themselves out, so to speak, and then we get others. I'm wondering if this Great Red Spot's something similar, you know, but in this case, it lasts for centuries on Jupiter, fades away, and then another century or so later, it comes back. Possibility. Numerical simulations and future research. Now, in a third set of numerical experiments, the research team explored the generation of the GRS from a known instability in the winds that is thought to be capable of producing an elongated cell that encloses and traps them. Such a cell would be a proto-GRS, a nascent red spot whose subsequent shrinkage would give rise to the compact and rapidly rotating GRS observed in the late 19th century. The formation of large elongated cells has already been observed in the genesis of other major vortices on Jupiter. I wonder if we've observed similar things. We know, as I say, Saturn and Uranus and Neptune, they have storms in their gaseous atmospheres, etc. If we've noticed the formation of these storms on other planets in our solar system, something we should look up and check it out and do a little video on it, perhaps. All right, so in our simulations, maybe we could learn something from it about Jupiter if these storms are generated similarly on other planets. In our simulations, supercomputers enabled us to discover that the elongated cells are stable when they rotate around the periphery of the GRS at the speed of Jupiter's winds. Right, so we've got elongated cells when they rotate around the periphery of the GRS. I'm wondering if these could be expanding into more GRSs in the future. Some do, some may not. Yes, so they rotate around the periphery of the GRS at the speed of Jupiter's winds. It would be expected when they form because of this instability, said Enrique Garcia Melendo, researcher at the UPC's Department of Physics. Using two different types of numerical models, one at the UPVEHU and the other at the UPC, the researchers concluded that if the rotational speed of the proto-GRS is lower than that of the surrounding winds, the proto-GRS will break up, making the formation of a stable vortex impossible. Okay. And if it is very high, the properties of the proto-GRS differ from those of the current GRS. Okay, so it's obviously under certain conditions that these others will break up and not become larger. I'm wondering, is this thing, as I say before, I wonder when this the major GRS shrinks, that will provide less resistance for the proto-GRSs to become full GRSs. That's me thinking aloud. Yeah. Excellent. So we got future research will aim to try and reproduce the shrinkage of the GRS over time in order to find out in greater detail the physical mechanisms underlying its sustainability over time. At the same time, it will try to predict whether the GRS will disintegrate and disappear when it reaches a size limit, as might have occurred to Cassini's PS, or whether it will stabilise at a size limit at which it may last for many more years. Interesting. And there's the link for the reference there. Reference the origin of Jupiter's Great Red Spot by Agustin Sanchez La Vega and Enrique Garcia Melendo and John Lagareta, Ana Amiro, Manuel Soria, and Kevin Arens Velasquez. 16th of June 2024 in Geophysical Research Letters. Absolutely fascinating. Definitely. Well done, gentlemen. That is very, very good. I'm very impressed, actually. Yeah, so there's Jupiter, its great red spot, and seems to be disappearing. And then again, I'm wondering whether once this one dies out, the other ones that don't make it because this one's consuming, too much, it's too big for it, and the others can't make it. I'm wondering once this goes, the others may pick up. Yeah, interesting. All right, well, my name is David. Thanks for joining me for another Studio 64 Science, Space and Tech News update. I shall see you in the next one. If you enjoyed this video, please like, share, subscribe. I'd greatly appreciate it. If you're up for it, drop a comment down below the video because I'd love to hear what you think. All right, take care, and as I always say, if you can't be good at it. And as I also always say,
my brain hurts!
5, 4, 3, 2, 1, fire!